Now with fragments and portals, we had two cool features that help us write cleaner HTML code. The app worked in exactly the same way before we added those features too. But with those features, we end up with semantically more correct HTML code. And that's never a bad thing. Makes your app more accessible, makes sure you don't render unnecessarily many divs, and in general shows that you are a developer who knows what he's doing. Now let me move on to one last key feature which I also want to show you, which does something different than fragments and portals though. And that would be refs. References, but the name in React is just ref, so the short form of reference. What do refs do? Refs are actually quite powerful, as we will see throughout the course, but in their most basic form, they allow us to get access to other DOM elements and work with them. Now, what do I mean with that? Let's go to the add user component again. There we have our inputs, and we manage what the user enters by simply keeping track of it. We simply have our state, and with every keystroke, we update our state. So with every keystroke, we update the value we get by the user, and we store it in our state, and we feed that state back into the input, and we then use that state later on to reset the inputs, but also to send it to the place where we need the data. So that is a perfectly fine way of managing this. But updating the state with every keystroke, when we only need it when we submit the form, sounds a bit redundant to me. And that's a scenario where refs could help us, though they're not limited to that. I will already say that. How do refs work? With refs, we can set up a connection between a HTML element, which is being rendered in the end, and our other JavaScript code. And for that, we first of all need to create a ref, which we do with the help of another React hook. We use the useRef hook here, and we then simply call useRef here in our code, in our functional component. And like all React hooks, useRef is only usable inside of functional components. Now, what does useRef return and which value does it take? It takes a default value you want to initialize it to, but we don't need this here. But I'm very interested in what it returns, because it returns a value which allows us to work with that ref later. So which allows us to work with that element to which we're going to connect it. And therefore here I'll name this name input ref, because I plan on connecting this ref with that first input which allows us to enter a username. So here we have the name input ref. Now I'll duplicate this and create another ref by calling useRef again, and that will be my age input ref. So now I got two refs, and they're just sitting there doing nothing. They're initialized to be undefined, because that's the default, and they're useless. Now we can let React know that we want to connect a ref to a HTML element by going to that element to which we want to connect the ref, and adding a special prop there, the ref prop. Just like the key prop, that's a built-in prop which you can add to any HTML element. Because, and that's important, you can connect any HTML element to one of your references. You will very often do that for inputs because you want to fetch input data, for example, but you can do it with any element. So here I got my ref, and now I will pass name input ref as a value here. And name input ref is just that constant which stores this first ref. So with that, I am connecting this ref, which I created in this component, with that JSX code that is rendered by that same component. And now a connection will be established. The first time React reaches this code and renders this code, it will actually set the value stored in name input ref to the native DOM element that is rendered based on this input. And that's important. What will end up inside of name input ref in the end will really be a real DOM element later. So let's do the same for the age. And here I'll connect this to age input ref. And that's now connected as well. So now the refs are connected. What's the benefit? Let's go to our add user handler function, and after event prevent default, I want to console log my refs. Let's start with the name input ref. If I log this here and I go back and I go to the console so that I can see the log, if I submit this, you see there's an object being output here. There is an object being output here, and that object has a current property. Now, that's important. This ref value, which is being generated here, always is an object which always has a current prop, and the current prop holds the actual value that ref is connected with. Now, by default, it's undefined, but as soon as this code ran, because of this ref prop, the name input ref is connected to that input, and hence, it's actually the input which is being stored as a value in the current prop. And what's being stored here really is the actual DOM node. So not some theoretical value or anything like that, but the real DOM node, which you could now manipulate and do all kinds of things with. Now, it is recommended that you don't manipulate it. Your DOM should really only be manipulated by React. You're using React to let it do all the heavy lifting. But reading data from the input doesn't sound too bad, because you're not changing anything with that. You're just reading data. So here, instead of logging this here, we can, of course, read current value. Now, current refers to the value stored, and the value stored is the input element, and every input element has a value property in JavaScript. We can actually see this here. There's the value property. So if I now save this and I log this value, if I enter max here, you see max being logged here. And that's pretty cool, because that means we can get access to the value stored in the element without having to log every keystroke. We don't need state for this. We can just read it when the submit button is pressed. So that means we could now replace console log maybe with a helper constant, which we use inside of add user handler. I'll name that constant entered name and simply store my current value in that. And I do the same for the age. I add my entered age and store age input ref.current.value. Now, entered age clashes with my state here, so therefore I'll pick a slightly different name. I'll use entered user age here. Now we can check entered name here and entered user age here, and also entered user age here in this condition. So always the values we retrieved from the refs. And I also use entered name here and entered user age to submit it to on add user. Now with that, of course, we should no longer reset these inputs by resetting the state here though, because we're not using the state to get our values anymore. We currently still have those listeners, but we actually now don't really need those values anymore. We're using refs to get the values. So what we could do is we could get rid of these states here. So of these states where we listen to every keystroke. Therefore, get rid of these state updating functions and get rid of these two handlers. And also get rid of the value property and the onChange property on the inputs. With that, we shortened that code quite a bit, and we're relying on refs to read the values. Hence, if I add max 31, you see we still can add that user. However, during the process, we lost our resetting logic. Now, to bring it back, we got two options. We can switch back to the state-based solution, which is not bad, but I want to show refs here. Or we do something which you should rarely do, but which actually is okay here in the context of an input field value which you want to reset. You can manipulate the DOM without React. And yes, I said you shouldn't do that. You typically shouldn't do that. But if you just want to reset the value entered by a user, it is something you can consider doing. So we could use the name input ref dot current dot value and now set it to an empty string and repeat this for the age input ref. And with these two lines added here, if we now check this again, you see now it's cleared. Again, rarely do that. Rarely use refs to manipulate the DOM. Here, we're not really manipulating the DOM, we're not adding a new element or changing a CSS class. I'm just changing what the user entered. You could argue that you don't even want to do that, and in that case, you can always return back to the state-based solution, but I think it's fine. Now, in general, the question is not whether refs or state is better. You can use either of the two. You will sometimes have use cases where you just want to quickly read a value, for example. And if you only want to read a value and you never plan on changing anything, well, then you don't really need state. Because just to use state as a keylogger is not that great. It's a lot of unnecessary code and work. So if you just want to read a value, refs are probably better. In scenarios like this, it's up to you what you prefer. Refs, which are a little bit less code, but you have this edge case of manipulating the DOM, or state, which is definitely cleaner, but is a bit more code. It's up to you, but we'll see refs throughout this course, and you will see them in a lot of projects, in a lot of React projects, because getting access to elements is quite convenient. And as I said, they can even do a bit more than that, but we'll see them again throughout the course. This is just an introduction, and this is all you need to know about refs right now. Now, in the last lecture, we learned about refs, and I showed you that with refs, you have an alternative way of getting that user input, of accessing those input fields. And I also showed you this a little bit hacky approach of then still manipulating the input fields and resetting them if you want to do that. Now, this approach of using refs to interact with DOM elements, specifically with input elements, also has a special name. We're talking about uncontrolled components if we access values with a ref. So these input components here would now be uncontrolled components. Why uncontrolled? Because their internal state, so the value which is reflected in them, is not controlled by React. We rely on the default behavior of the input, where a user, of course, is able to enter something and that entered value is reflected. And we then just fetch it, yes, with a React feature, but we don't feed data back into the input. When I set a new value to those inputs here with this workaround, we're absolutely not using React here. Sure, we're using the ref, but in the end we get access to the native DOM element with that, and I then just use the regular DOM API for setting the value of a DOM node, of an input DOM node. So that's why this is uncontrolled, because we're not controlling the state of the input element with React. Now, you can talk about uncontrolled and controlled components also in the context of other components. But most commonly, we have this scenario when we talk about input components, about form components in general. Because those components tend to have some internal state natively by the browser. An input element is configured to take user input and save and reflect it. And when we then work with those components in a React app, we want to connect our React state to that. That's why we typically have this controlled, uncontrolled thing when we work with input components in React. And when we use refs, like we're doing it here, we have uncontrolled input components. The approach we had before, where we manage our state and we update that state on every keystroke and we feed that state back into the input with the value prop. So that approach we had before we added refs, that would be the controlled approach. Then we would say that those input fields are controlled components because their internal state is controlled by React. These are simply important terms which you should keep in mind for potential interviews or discussions with other React developers because they are typical terms you hear in the React world. Now, with the core basics and the foundation about React and its most important features out of the way and applied to our course project, we're gonna take the next step in this module. We're gonna have a look at 3 very important concepts which you need to know as a React developer. And that will be effects, reducers, and context. Now, these features are a little bit more advanced, which does not mean that they're difficult. This just means you need to know the other concepts first, which is why we are now diving into those concepts here. And with those features, you will be able to make a huge step forward towards more complex React applications. Now, in this module, we will therefore take a closer look at what effects are and how you can work with so-called side effects, which is what effects means, but more on that in a second. We'll have a look at how we can manage more complex state in our components with reducers. And we will explore app-wide or at least component-wide state, so the state that affects multiple components, with a concept called context, which is built into React to make sharing state and state updates across components easier. A lot of important features that are included here, so let's not waste any time and let's dive right in. So what is an effect, also called a side effect? And I will use these terms interchangeably. So when I say effect, I mean side effect and the other way around. But what is that? Well, let's not forget that our components in the React app and our React app as a whole, and also especially the React library itself, has one main job: to render the UI, to react to our user input, to re-render the UI when it's needed. That is what we focused on thus far. With state and events and all of that, the main job was to bring something onto the screen and to make sure that the user may interact with that something and that what's shown on the screen may change based on certain events, for example, based on a button click or some text being entered. So therefore, that's the main job of React and of our application. We want to evaluate and render the JSX code and the DOM. We want to manage state and props to make sure that every component has the data it needs and that we reflect the user input correctly. We want to react to user events as mentioned. And of course, React is there to also re-evaluate our components and their JSX code and manipulate the real DOM as needed. So that's all baked into React with the tools and features we learned thus far and which we will dive into throughout this course, of course. So something like the use state hook, props, and so on. That's the main job. And if we have a look at a React component, this is a component from this module's project, which I'll dive into in a second. Then we learned that a component is just a function, therefore it's executed top to bottom, and everything in that function in the end deals with bringing something onto the screen and or with reacting to user input, to clicks, and so on. So that's what this function is all about. We may use state in there, we may have other functions in there, which for example are triggered upon a button press and so on. But everything we have in this component function is concerned with bringing something onto the screen. Now, therefore, side effects are everything else that might be happening in your application. And a good example here is sending a HTTP request or storing something in browser storage, in local storage, for example. But you could also think about timers or intervals which you set in your code. These are all tasks which you of course often have to consider in your application. For example, a lot of web applications need to send HTTP requests to backend servers, but these tasks are all not related to bringing something onto the screen, at least not directly. Of course, you might be sending a HTTP request to then draw something onto the screen once you got the response, but sending the request itself and handling potential errors and so on, That's not something you need React for. That's not something React cares about. That's not what React is there for. It's not something that is related to drawing something onto the screen directly or anything like that. So these are therefore tasks which must happen outside of the normal component evaluation. So outside of your normal component function. Because you must not forget that this function, this app function, for example, is re-executed by React automatically whenever, for example, the state in this component function changes. Whenever this isLoggedIn state would change here, this entire function reruns, and React then basically checks what the new result of this function execution, so the new JSX code, looks like, and if, compared to the previous result, it should go to the real DOM and make some changes there. And we'll dive deeper into how exactly React works under the hood in a separate section, but this is what you learned thus far, and this is what React does. Now, since this is what's happening, if we would send a HTTP request, for example, directly here, then we would send this request whenever this function reruns. So for example, whenever this state changes. And that might sometimes be what you want, but definitely not always. And if in response to your HTTP request, you, for example, eventually change some state, you would even create an infinite loop. Because you would send a request whenever the function reruns, and in response to the request, you change some state which triggers this function again. So therefore, such side effects should not go directly into this component function, because that would most likely create bugs, infinite loops, or simply send too many HTTP requests, to stick with that example. Therefore, we'll have a better tool for handling side effects, and that's a special React hook which we can use, the useEffect hook. The useEffect hook is simply another built-in hook. So another function you can run inside of your component function that will do something special. The useEffect hook is called with two arguments, with two parameters. The first argument is a function that should be executed after every component evaluation if the specified dependencies changed. And the specified dependencies are the second argument that you pass in. That's an array full of dependencies, and you will see how these dependencies look like throughout this module. So an array full of dependencies, and whenever such a dependency changes, that first function will rerun. And therefore, in that first function, you can put any side effect code, and that code will then only execute when the dependencies specified by you changed, and not when the component re-renders. So only when your dependencies changed. Now let's have a look at that in action, and for that I prepared a little project which we're also going to have a look at. So attached you find this project here. You can simply download it, extract it, run npm install inside of it, and then npm start, and you will see this page on localhost 3000. Now that's a very simple dummy app where you can enter any credentials of your choice. That's not a real authentication screen yet. For the moment, it's just a dummy screen. As long as you have a valid email address and a password that is at least 7 characters long, you can click the login button and you're on this dummy welcome screen. These links won't do anything, but the logout button will take you back. So it's a very simple dummy app. At the moment, there is no real authentication logic. We'll dive into that in a separate module. But it is a good enough example to practice the useEffect hook and side effects therefore, and also the other core concepts of this module. So what's up with this useEffect hook now? Well, what could be a good side effect here? Sure, we could send a HTTP request to a backend server, which validates our email and password. But at the moment, we have no such server, so therefore I want to do something else. At the moment, when I log in with any dummy credentials, which are an email and at least 7 characters long for the password, if I click login, I am logged in this dummy mode, But if you reload this page here, you always lose this login status. And that is probably not something you want. Now, in reality, you would, of course, once you log in, send a request to the backend and get back some login data. For example, some token which identifies this user as authenticated. Again, more on that in the authentication module. But you want to make sure that this user is authenticated status is also still there once you reload the page. At the moment, we lose this because in the app.js file, where I manage this simple isLoggedIn state, it's just managed as some React state. And therefore, it's just, in the end, managed in some JavaScript variable behind the scenes by React. Now, the nature of that is that when you reload your application, your entire React script restarts, and all variables from the last execution are lost. That's how the web and scripts and the browser works. This is nothing React specific. Now, since we lose all the data when this restarts, it would be nice to store it somewhere where it persists the reload. And even better than that, we also want to make sure that whenever this app does start, we check if the data was persisted. And if it is, we log the user in automatically so that the user doesn't need to re-enter the details. And that's where we can use useEffect. Now let's start with storing the data. Here in the logged in handler, I set isLoggedIn to true. And that's where I want to store that piece of information in the browser storage. Now the browser has multiple storages we can use. The most common storage for this would be cookies or local storage. And since it's particularly easy to work with, we will use local storage. So that's a storage mechanism built into the browser, totally independent of React. Here in the login handler, we could therefore run local storage. This is a global object which is available in the browser. Set item, and then give the item any identifier of our choice, like for example, is logged in. But that's totally up to you. It should just be a string though. And the second argument should also be a string which you store. And for example, that could be 1 to signal that this is that the user is logged in. 0 could stand for not logged in. Of course, you could also have some identifier like this. This is totally up to you. I will work with 1 and 0. So we can set this item here. And if I do this and I save everything, if I do log in again here, I can open up the developer tools thereafter. And there open the application tab or the application part. There you'll find the storage section with the local storage. And if you expand this, you'll find your host, and there you should now find this key value pair. That's stemming from this line. So that's how we can store data. Now we can do this here in the function because it is a function that executes only when the user clicks the button, which is rare enough and which is exactly when we want to store something. So that's now a use case where we don't need useEffect necessarily. But how about the scenario that the app restarts because the user left the page and comes back, or simply because we reload the page? Then we want to check if in local storage we have that key value pair. Now, when the app restarts, this app component function runs again. Now, therefore, here, of course, in this function, we could reach out to local storage, call getItem and search for isLoggedIn, and this will return the item stored there. So that's the stored user logged in information. That's a super long name. Obviously, I just want to make it clear what's in there. You would typically use a shorter name, of course. And we could check if the stored user logged in information is equal to 1. And if it is equal to 1, we could call set isLoggedIn and set this to true. So that we set the user to logged in even without this function being triggered. And it would trigger upon pressing the login button normally, just because we know that the user is logged in. And of course, we should do that after calling useState. So we could do that. But the huge disadvantage with that approach is that we would create an infinite loop. because we check for this being stored. If it is stored, we set this to true. And whenever we call a state setting function, this component function re-executes. And therefore, this would run again, would find 1, would set it again, and so on. That's what I explained earlier. So we need useEffect here, because that allows us to control when this runs. Hence, from React, besides useState, we import useEffect like this. And then here, we can simply call useEffect, just like this. And now we pass those 2 arguments you saw on the slide to it. The first argument is a function, for example here, an anonymous arrow function. Doesn't have to be an anonymous arrow function, but often you use just such a function. The second argument is an array of dependencies. Now I'll come back to those dependencies later. For the moment, let's just write it like this. In this function, we can now run this code here, which we don't want to run directly in the component function. Because now this function here is executed by React, and it is executed after, important, after every component re-evaluation. So whenever this component function ran, thereafter, this will run. And if you then update the state in here, the component will run again. But it will not just run after every component evaluation, but only if the dependencies here changed. Now, when the app starts for the first time, that will be the case. If this component function runs for the very first time because your app just started, then the dependencies are considered to have changed because you had, well, no dependencies before, you could say. But once it ran for the first time, for example, with this setup here, we have no dependencies, but therefore, of course, they also didn't change compared to the first execution cycle. So therefore, this anonymous function here would indeed only run once when the app starts, because thereafter, well, the dependencies never change because this here specifically has no dependencies. And in this scenario, that's exactly what we want. We want to run this code once, and that's when our app starts up. So therefore here we should have exactly the behavior we want. Once the app started, this code runs. Here we update the state, and as you learned, this triggers this component function to run again. Now therefore this all runs again, this JSX code is evaluated, and the DOM is updated accordingly, but thereafter the effect would run again, but only if our dependencies also changed. And that's not the case here, as I explained. So therefore, this should only run once. And hence, if we save that, and I reload here, you see I'm logged in. I don't end up on the authentication screen, but in the logged in state. And the reason for is that we have this stored. Now, if I clear that manually by selecting it and deleting it, if I now reload, you see I'm back here. Because this code still ran, but of course it didn't find the logged in information. If I do log in again, so that this is stored, you will see we're back to the behavior from before. If I reload, I end up on this page. So that's useEffect, and that's one scenario where it shines a lot. This data fetching is a side effect. It's not directly related to the UI. Of course, the result is, but not the data storage access itself. And we want to run it as a side effect with useEffect in this case to avoid an infinite loop and to make sure that this code, which potentially could also be performance intensive, does not run for every component re-render cycle, but only if we want it to run. Now let's refine our data storage example here by also making sure that when we click the logout button, we again reach out to local storage and we remove the is logged in key there, simply to clear it from there so that we don't have to clear it manually by selecting it here.